Okay, so today we're going to talk about logarithms. In order to talk about logarithms, which is something that some of you might have never heard of before, um, they're closely related to exponents. So let's talk about exponents really fast. So we'll say 2 to the fourth equals what? Well, 2 to the fourth means we're going to multiply 2 times 2 times 2 times 2, and this is going to get me 4 times 2 is 8 times 2 is 16. Easy enough. Okay, so what does logarithms have to do with this? Well, the question that you ask yourself when you're talking about logarithms would be 2 raised to the what power equals 16? Well, we just did that here. So this would be x equals 4. And this is pretty much what logarithms boil down to. Let's go over the formal definition for a logarithm. Okay, so if we have log, and then the way we see this is log base b of y is equal to x if and only if, okay, if and only if b raised to the x power equals y. Okay, so if we go back to our first example, this was 2 to the fourth equals 16. Okay, my 16 is y, my 4 would be x, and my 2 would be b. So how would this be written in log form? Okay, so we're going to come back up here and we're going to use this. So this is log base b. What is b here? Well, it is 2. So log base 2. And then my y is here, which is 16 equals 4, which is my x right here, and it's 4. So like I said before, they're very, very closely related to exponents. So if we come here and I say, okay, so we want log base 2 of 8 equals 3, and I say, I want to write this in exponent form. Okay, well, exponent form, which is the form that we are familiar with, okay, this would be whatever the base is. What I like to say is this is the base of our exponent, so this is 2 raised to the third power equals 8. So this is the exponent form, this would be the logarithm form. Okay, let's do another one. Log base 12 of 12 equals 1. Exponent form would be 12 raised to the first power equals 12. Easy enough. Okay, so now let's evaluate some logarithms. Okay, so we want to evaluate the logarithm. Okay, so our first example will be log base 4 of 64. Okay, so we want to evaluate this. We always want to convert this into exponent form, so that way it's familiar to us. Okay, so we want to evaluate this, so basically this equals x. That's what I'm looking for. I want to know what this equals. Okay, so if we remember, 4 is the base, so this is 4 raised to the what power? That is the question we ask ourselves all the time when we're evaluating exponents. 4 raised to the what power equals 64. So 4 raised to the what power equals 64. Okay, so we know that 4 times 4 is 16, times 4 is 64. So 4 cubed is 64. So what's my answer here? My answer here is x equals 3, or this logarithm is evaluated. When you evaluate it, you get 3. Okay, so that was a pretty easy one. Let's go over a little bit more difficult one. So we want to evaluate this logarithm. So this is log base 36 of 6. What is this? What does this equal? So this is going to be 36. This is my base, 36 raised to the what power equals 6. Okay, so we're going to have to remember back when we were learning about rational exponents. Okay, so the relationship between 36 and 6, we know that 6 is the square root of 36. So 6 is the square root of 36. So we need to raise this power to say the square root. Well, how do you write a square root in terms of exponent? Well, the square root of 36 is the same thing as 36 raised to the 1/2 power. So this is going to say 36 raised to the 1/2 power equals 6. So my answer is going to be x equals 1/2. Remember that raising a number to the 1/2 power is the same thing as taking the square root. Refer back to your rational exponent notes if you're not quite too sure about that. Okay, let's go over one more. So this is going to be log base 1/5 of 125. What is this? And now I'm sure you're thinking, crap, there's a fraction. What the heck are we supposed to do? Well, this is actually pretty easy as long as we get this in exponent form. So this is going to be 1/5 raised to the what power equals 125. Recall back again to the properties of exponents. Whenever you have a negative exponent, so if this is negative, it flips this. Okay, so we know that 5 cubed is 125. 1/5 cubed is 1/125. So here, if we can get this to flip this one and this one, we would get 125. How do we do that? We make this exponent negative. Again, properties of exponents. So 1/5 raised to the -3rd power is 125. So what does my x equal? My x equals -3.